Hello class, today we're going to work on solving systems algebraically, which is in section 3-2, part 2 of your book. Our objective is to solve linear systems using elimination. So in example 1, we were asked to solve by elimination. So it says, what is the solution of the system of equations? So we have two equations that form our system. It says 4x plus 2y equals 9 and negative 4x plus 3y equals 16. What's nice is for us to use elimination, our goal is to eliminate a specific variable. And for us, this variable is already in opposite format to be eliminated, and that variable is x. Notice in the first equation there's a positive 4x, and in the bottom equation there's a negative 4x. So we will cancel them. So negative 4x and positive 4x cancel, and you're left with 2y and 3y. So we're going to combine what's left over. So 2y plus 3y is 5y, and 9 plus 16 is 25. If we divide by 5 on both sides, we will get the y part of our solution as 5. We'll then take that 5 and substitute it into either the top or the bottom equation. And I'm going to put it into our upper equation because they are all positives. So if I rewrite that, I will have out to the side 4x plus 2 times y, which is 5, equals 9. That gives me 4x plus 10 equal to 9. If I subtract 10, that gives me 4x equal to negative 1. And then finally, if I divide by 4, I get x equals negative 1/4. So as a final answer, because remember a solution should be an ordered pair, as a final solution, we will get the ordered pair negative 1/4, 5. And that will be our final answer. All right, in our try 1, it says, what is the solution of the system of equations? So again, we're going to go ahead and solve. Readily available, the variable that's set up as already being opposites is the variable y. We have a positive 8y and a negative 8y, so they will cancel one another out when we combine. And if we continue to combine like terms, we will have left over 3x equal to 12. If we keep going, we will divide by 3 and we will have x equals 4. Now again, we want to substitute this x equals 4 into one of our equations, and I typically like to choose the equation that has fewer negatives and easier numbers to work with, so that's going to be our second equation. So if I substitute 4 in for x, I will have 5 times 4 minus 8y equal to 20. That's 20 minus 8y equal to 20. If I subtract 20, we will have negative 8y equal to 0. Finally, if we divide by negative 8, we have y is equal to 0. Again, we cannot leave our answer like this, so our final answer as an ordered pair will be 4, 0. And again, that is our final answer. All right, so in example 3, we're going to switch it up a little bit. So we're using equivalent systems, and equivalent systems basically just means that in order to eliminate a variable, you have to come up with an equivalent number that then you can make opposites of to be able to cancel. So for example, if I wanted to eliminate my x's first, a common multiple of 2 and 3 would be 6. So I would choose force one of my x's to be positive 6, and I would force the other one to be negative 6. If I wanted to eliminate my y's, for example, a common multiple of 7 and 5 is 35. So I would have to force one of them to be positive 35 and the other to be negative 35. I'm going to choose, however, to get rid of my x's or to eliminate my x's. So let's start there. So to eliminate my x's, I need to force one of them to be positive 6 and the other to be negative 6. So I'm going to make the upper equation positive 6 and the lower equation negative 6. So to force 2 to be positive 6, I would have to multiply by 3. To force the bottom equation to be negative 6, I'd have to multiply the entire thing by negative 2. So let's rewrite. If I distribute 3 to everything in the top equation, I'll have 6x plus 21y equal to 12. If I distribute negative 2 to everything in the second equation, I will have negative 6x minus 10y equal to 10. All right, so now it's pretty obvious our x's are gone. And then we continue to combine like terms. So 21 and negative 10 gives me 11y. 12 and 10, if I combine them by adding, I get 22. I want to get a y by itself, so I'm going to divide both sides by 11, and I get y equal to 2. Remember, that's only 1/2 of our answer. Now again, I'm going to go back to my original equations and figure out where I'm going to substitute y, 2 for y. So it looks like the upper equation is easier, or maybe easier for us, because it has all positive numbers and variables. So I'm going to substitute my y into that equation. And so I'll have 2x plus 7 times my y, which is 2, equal to 4. So that gives me 2x plus 14 equal to 4. If I subtract 14, it gives me 2x equal to negative 10. And finally, if I divide by 2, I'm going to get x equal to negative 5. So as a final ordered pair solution, we'll have negative 5, 2 as our answer. An example, or try 2. Again, we're using equivalent systems, so let's think about what we want to eliminate. Remember, if we wanted to eliminate the x's, 3 and 5, a common multiple would be 15, so I would need to make one of them a positive 15 and the other one a negative 15. With the y's, if I wanted to eliminate the y's, that means the common multiple would be 14. So one would have to be positive 14 and the other one would be negative 14. In this case, I typically just like starting with numbers that I really like to deal with. And 3 and 5 is a fairly easy one to deal with. So I'm going to eliminate my x's here. So if I make the top one positive 15, I'm going to multiply by 5. If I make the bottom one negative 15, I'm going to multiply by negative 3. So here we go. If I distribute that to everything, the 5 to everything, I'm going to get 15x plus 35y equal to 75. On the bottom one, if I distribute the negative 3 to everything, that will give me negative 15x minus 6y equals 12. X's are gone. 35 minus 6 will give me 29y. 75 plus 12 will give us 87, sorry. If we take 87 and divide it by 29, we will get 3 for y. All right. Again, I'm going to substitute that y equals 3 into one of my easier, or my more comfortable equations. So I'm going to put it into the first one because it has all positives to deal with. So if I rewrite to the side, I'm going to have 3x plus 7 times y, which is 3, equal to 15. Common mistakes are people substitute the correct variable into the wrong location. So they may put this 3 in where they see x rather than y. So just be careful. So we have 3x, 7 times 3 is 21. Next, we're going to subtract 21. And we have 3x equal to negative 6. Finally, divide by 3. And x will equal negative 2. So our solution for this example, or this try, will be negative 2, 3. All right, finally, there are some times where we will have unique solutions. And so let's take a look at what happens when we're faced with those types of problems. So for our first one, the x's are already in opposite formation. We have a positive 3x and a negative 3x. So they will cancel, but not only are the x's opposite, but so are the y's, and so are the 5's. So let's not forget that this is an equation that should be balanced on both sides. So on the left side of the equal sign, I see a 0 that's left over. And on the right-hand side, I see a 0 as well. Let me make that a little bit more easier to read. So if 0 equals 0, essentially what you're saying is that those lines are equal to one another. If those lines are equal to one another, the amount of solutions that they have, well, let's think about it. If this were a graph and it were overlapped with another graph that was the exact same, solutions are the amount of points along that line. So this graph has an infinitely many solutions because they are equal to one another. On our next problem, it looks like the x's and the y's both are eliminated. So I'm left with 0 on the left-hand side, but on the right-hand side, I'm left with 16. What that tells me, first of all, we know that 0 is never equal to 16. So that means that those lines are not equal. And for the most part, to ask how many solutions there are, that's pretty simple. We'll just say no solution. They're not equal, so there will be no solution. Let's take a look at our try. All right. On this first one, in order to eliminate, we have to find an equivalent number. So let's say we want to eliminate our x's. I see a -1 and a +2. So an equivalent number that 1 and 2 share together are 2. So I can make this upper one -2 if I multiply by 2. And if I keep the bottom one the same, it will be +2. So let me rewrite. If I distribute the 2 throughout, I will have -2x plus 2y equal to -4. Sorry, that's kind of hard to read. Let me switch back. And if I just rewrite this one back down here, I have 2x minus 2y equal to 0. Well, again, look what happens. The x's go away, the y's go away, so it leaves me with 0. And -4 plus 0 is -4. 0 never equals -4, so that is no solution. There's no solution for that one. On the next one, again, we have to do an equivalent fraction. It looks like the y's might be a little easier to work with because one of them is already a +3y, so I'm going to force the other one to be a -3y by multiplying by -3. That's just not showing up, is it? -3. So we're going to distribute that, and we're going to get -12x minus 3y equal to -18. Let me go back and switch to my regular one. The second equation, as it was originally written, is 12x plus 3y equal to 18. Again, my x's, my y's, and my number at the end are all gone, and I'm left with 0 equal to 0. If 0 equals 0, that means that the lines are the same, and again, it is infinitely many solutions. And that is it. Guys, if you have any questions or you need to come see me for tutoring, please don't hesitate to do so.